Okay, students, so let's start with the past papers of modes of thermal energy transfer. This is applicable for both O levels and IGCSE physics. So let's see this question. Figure 3.1 shows a man standing underneath an outdoor heater on a cold evening. Okay, this is a man standing underneath a heater on a cold evening. Okay, gas in the cylinder at the base of the heater. Okay, so gas somewhere here. Okay, is the fuel for the heater. When the heater is operating, the gas travels to the top of the heater where it burns. Okay, state the form of energy stored in the gas that is transferred by the heater. Chemical energy. Chemical energy. Okay, let's further move ahead. A metal screen surrounding the burning gas is heated by the a metal screen surrounding the burning gas is heated by the burning gas until it is red hot. The hot metal screen warms the man who is standing underneath it. So let's see what is happening actually. Okay, we have some amount of heat here. This goes here on the red hot screen, and this red hot screen in turn heats the man. Okay. Perfect, perfect. Understandable, understandable. And describe how thermal energy in the red hot metal screen is transferred to the man and how it warms him. Okay, so how the thermal energy from this one, red hot metal screen is transferred to the man and how does it warms him? Let's see that. So, what will you say? Radiations are emitted from this hot surface. They travel towards the man, and the man absorbs this radiation, causing the internal energy of the man to increase. So, what will you write here? The hot metal screen, the red hot metal screen. Let's obey whatever the question is saying. The red hot metal screen emits radiations. These radiations travel towards the travel towards the person, towards the man, and the man absorbs these radiations. Absorbs these radiations. Okay, last point. Last point. As the man absorbs these radiations, what happens? His internal energy increases. His internal energy increases. Simple. Let's further move ahead. At the top of the heater is a metal hood that has a shiny surface. Okay. Explain why this makes the energy transfer from the metal screen more efficient. So, this is the metal hood that we are talking about. This is a shiny metal hood or surface. How does this makes the process of heat transfer more efficient? Yes. What can you say here? You can say that heat will get reflected back from this metal surface. This will reduce the losses of heat, increasing the efficiency of heat transfer. You will say the shiny surface reflects back most of the heat, most of the heat. This causes a reduction in the loss of heat. This causes a reduction in the loss of heat. Hence, efficiency increases. Hence, efficiency increases. Okay. The air temperature decreases and the man puts on a black pullover. Explain one way in which wearing the black pullover helps to keep the man warm. Black surfaces are good absorbers of heat. Absorbers of heat. The black pullover allows the man to to absorb, to absorb a large amount of heat, and this keeps the man warm. Simple as that. Okay, let's see this question. Figure 2.1 shows a hollow metal cube filled with boiling water. The temperature at the four vertical surfaces are equal, but each surfaces has a different color or texture. Okay, so this is the metal cube with different textures and color. Okay, a thermal radiation sensor is placed the same distance from each surface, and the meter reading measures the thermal radiation emitted from each surface. Okay, so a radiation detector is placed here that detects the radiation emitted from each surface. The results are shown in figure 2.2. Okay. Draw a line linking each type of the surface with the appropriate meter reading. One line has been drawn for you. So if you have a shiny but black surfaces, the number of radiations emitted will be 80. However, if you have a dull and black surface, what do you think? Number of radiations will increase. It will become 100. If you have a shiny and white surfaces, shiny texture is also a bad thing. White color also limits heat loss or is a poor absorber. Both the things are poor absorber. So this will have the least radiations, and dull white will have the remaining radiations, that is 60. Okay, let's further move ahead. The hot surface produce a convection current in the air outside the metal cube. Describe how convection current is produced. Now, this is so simple. I'm just writing it in a concise manner because we have done this same question so many times. What will we say? The hot, less dense air rises. Hot, less dense air rises. Cold, denser air takes its place. Takes its place. Convection currents are formed. Convection currents are formed. Simple as that. Let's move on to the next question. Figure 2.1 shows a black car going up a hill on a sunny day. One way in which the car is gaining thermal energy by burning lubricants or fuel. One way in which the car is losing thermal energy, heat loss to the surrounding. Heat loss to the surrounding. Okay. Let's see the next one. The car accelerates up a hill. In addition to an increase in thermal energy, there are other energies transfers taking place. Describe the other energy transfers that take place. The car accelerates, velocity is increasing, maybe kinetic energy is increasing. Up the hill, that means height is increasing, gravitational potential energy is increasing. So you will say chemical energy, that is the energy in the fuel, gets converted into what? Kinetic energy. And chemical energy also gets converted into what? Gravitational potential energy. Simple as that. And last part C. At one point in the motion, the kinetic energy is this, the mass is this. You have to calculate the speed of the car. 90 into 10 raised to the power of 3 is equals to 1 upon 2 into m into v square. This becomes 1, this becomes 400. Can you calculate the velocity? Yes, you can surely calculate the velocity. 90 into 10 raised to the power of 3 divided by 400, taken under root. The answer comes out to be 15. The answer of velocity comes out to be 15 ms minus 1. Let's move on to the next one. Figure 3.1 shows a hot water tank that contains two electrical heaters X and Y. Okay, heater X is used during the daytime, but heater Y is only used at night when the electricity is cheaper. Okay, the tank is full of cold water and X is switched on. Okay, X is switched on. The temperature of all the water above X increases very quickly, but the temperature of the water below X increases much more slowly. Explain the processes that causes the water above X to increase in temperature. Simple convection currents, you will say. Hot, less dense water surrounding heater X rises. Heater X rises. Cold, denser water sinks to ground. Sinks to the bottom. Convection currents are developed. Simple, simple one. Again and again, we are writing the same thing. Develop, this cause heating. Convection current develop, this cause heating. Heater Y remains switched off. Okay, explain why the temperature of the water below heater X increases much more slowly than the temperature of the water above heater X. This is much more interesting. Why does the temperature in this region increases much more slowly? Because in this region, no convection is happening. No convection is happening. And the only mode of transfer is conduction. And water is also a poor conductor of heat. So you were right. No convection happens below X. Happens below X. Below X. Only conduction occurs below X, and that is limited because water is a poor conductor of heat, because water is a poor conductor of heat. Let's move on to the next one. The hot water tank is covered in a thick layer of insulating material. The material is a plastic that contains a large number of small pockets of trapped air. Explain why this is a good insulator. Firstly, plastic is a poor conductor of heat. You can say that, poor conductor of heat. Secondly, the trapped air acts as a good insulator and limits convection currents. So this marks the end of theory past papers for modes of heat transfer. If you have any questions, you can ask.